Okay, looking at the MyiMaths exercise on scatter graphs. The first question says 10 students were asked how much time they spend on a computer each week and were then timed running 100 meters. Plot the last 5 points drawing a line of best fit. Okay, so each of these crosses that's already on the graph represents these pairs of data points. So for individual people, each person is a cross. And so, for example, the first person took 11.3 seconds to run 100 meters, having spent 8 hours on his or her computer. And that's reflected by this point here, 11.3 across, 8 up. So the horizontal axis is the time to run 100 meters, and the vertical axis is the hours they spent on the computer. So each of these crosses, 1, 2, 3, 4, 5, is one of these people. 1, 2, 3, 4, 5. And we've got to complete the scatter graph. So the next one is 15.8, 16. So that's 15.8 across, which is about there. And then 16 up. So just about there. Let's just get that in the right place. Yeah, I'm happy with that. Next one, 12.66. 12.6 and 6. Yep. 12.2 and 10. So 12.2 is about there, and then 10 up. 10 up is there, isn't it? Yeah. 14.5, 14. So 14.5 is right on the line, and then 14 up is there. And 11.5 and 5. So 11.5 is there, and then up by 5. Then it says draw in a line of best fit. So a straight line that kind of fits the pattern of those points. Now, strictly speaking, a line of best fit should go through the mean average point. So if you work out the mean average of all of the times in seconds and all of the times in hours, that gives you the average point. And the line of best fit should, strictly speaking, go through the mean average point of the two data sets. So the mean average is when you add them all up and divide by how many there are, so it should go through that average point. I don't think they've bothered about this on this particular MyiMaths exercise, so we will just freely try and draw a line of best fit through this. Now obviously different people will respond to this in different ways, because just trying to get this to work. Because it is a little bit subjective. There are mathematical techniques for figuring out the absolute best fit line, but at the moment, at this level in MYP2, you're just doing it by eye. Then it says, estimate the 100-meter time for a student who spends 13 hours a week on the computer. Now they want you to do this according to your line of best fit. So somebody spending 13 hours on the computer, if I read across from 13 until I hit my line of best fit, then it goes down to about 14.5 seconds. So according to my line of best fit, we would predict that somebody who spent 13 hours a week on the computer took 14.5 seconds to run the 100 meters. Now it's a bit of a badly designed question, because there is already somebody who ran who spent 13 hours a week on the computer, and they ran it in 13 seconds. So that's just trying to find them here. That's this person here, isn't it? So 13 seconds and 13 hours on the computer. So it is a badly designed question in the sense that there is already such a person in the data set, but they want you to do this according to the line of best fit, so make a prediction according to the general pattern that you've observed. Then the last bit, does the graph show positive or negative correlation? So positive correlation is when the graph increases from left to right. So it's going uphill, if you like. So as the time increases, so the number of hours spent on the computer increases. And that kind of makes sense. You would expect if somebody's not very fit, and then they might be spending a lot of hours on the computer, and then they're taking longer to run 100 meters. So if it's going up from left to right like that, and they're both increasing together, that's called positive correlation. If it's the other way around, where one decreases as the other increases, that would be negative correlation. Or the other possibility is if the crosses are all over the place and it's random, and that would be no correlation at all. Little footnote by me on this. I think they've got these axes the wrong way around, really, because conventionally, if one variable is dependent on the other, then you tend to put the dependent variable on the y-axis. What I mean by that is the number of hours you spend on a computer affects your ability to run 100 meters. And it's not the other way around. You can't say the time you take to run 100 meters affects the hours you spend on a computer. So when one variable is dependent on the other, you tend to put the independent variable on the horizontal axis, so that would be the hours on the computer, and then the thing that it affects, or the thing that's dependent on it, on the vertical axis. And in this case, you can see how the time to run 100 meters could depend on the number of hours you spend on the computer, but certainly not the other way around. So I don't agree with the way they've put the axes in this. But moving on to question 2. So it's another similar kind of thing, and I didn't actually mark that, did I? Let's just mark that. There we are, 10 out of 10. Moving on to question 2. So it's a similar sort of thing. Put the crosses in. So 47, 9. 47 is about there, and 9. Let's just get that right. About there. I've got to be careful here because it's 2 squares wide for 5 kilometers. So 47 is about there. 48, 12. So 48's about there, and 12 is there. Got to be careful to line it up correctly. 51, 7. So 51 is going to be about there, and 1, 2, 3, 4, 5, 6, 7. Okay, I'm happy with that. 56, 4. 56 is about there. 1, 2, 3, 4. And 59, 3. So 59 is about there, and 3. Okay, draw a line of best fit. So again, something fitting as best as I can through the data points, ideally with about as many points above it as below it. Doesn't want to draw that for me. Let's try that again. Oops. This is fun. Okay, I think we've got it. So that might not be the best line of best fit, but it's the one that they'll use in checking your answer for the next question. So estimate to the nearest whole number the weekly hours of sport for a student who runs 10 kilometers in 50 minutes. So I'll read 50 minutes and then reading across, well, it's somewhere between 6 and 7, a little bit nearer 7. So my prediction will be 7 hours to the nearest whole number. Okay, so does the graph show positive or negative correlation? So because it's going downhill from left to right, so as the time to run increases, then the hours playing sport decreases, then that's negative correlation. And once again, that's as we would expect it. If you spend a lot of hours playing sport, you get a lot of practice, and then the time it takes you to run 10 kilometers should go down. Again, I disagree with the way they've got these axes, because the time you spend running 100 kilometers could depend on the number of hours you spend practicing sport. So really, they should have the independent variable on the x-axis and the dependent variable on the y-axis. So I disagree with the way they've put the axes here. Let's just mark this, and it's 10 out of 10.